Namaste students. We have completed 2 chapters, matrices and determinants. From today onwards, we will be starting with another important topic called continuity. Continuity and differentiability is an important chapter wherein the weightage is around 20 marks. So we have to start with continuity first. Continuity. So weightage for continuity is 4 marks. 4 marks is the weightage given for continuity. So one question will be definitely asked in the part E section along with another 6 marks question. 6 plus 4, 10 marks weightage. So before moving on to continuity, we need to know basic concepts about limits. You should know about limits. You know, when the limit of a function exists, if you consider the function y is equal to f of x, let us consider a function y is equal to f of x. It may be an algebraic function, it may be an exponential function, it may be a logarithmic function, or it may be a trigonometric function, whatever function it may be. Let us consider generally y is equal to f of x. Suppose if you say that limit as x tends to a, f of x is equal to L. If you say that limit as x tends to a, f of x is equal to L. What is the actual meaning of this? The actual meaning of this is as x tends to a, f of x tends to L. That means as and when the value of x approaches a, then value of f of x approaches L. Okay? So when the value of x approaches some quantity a, then f of x value correspondingly approaches to the value L. That's what the actual meaning of limit is, limit concept. So when you limit the value of x, then obviously limit of f of x will be defined. That means when x tends to a, then value of x approaches a, then value of f of x approaches L. So we have already learned limit as x tends to a minus f of x. This is called as left hand limit. This is limit as x tends to a minus is called as left hand limit, and limit as x tends to a plus f of x is called as the right hand limit. Right hand limit. You know, left hand limit and right hand limit. And you know that limit of a function exists only when limit as x tends to a minus f of x is equal to limit as x tends to a plus f of x. So value obtained in LHL, that is left hand limit, and value obtained in RHL, right hand limit, that should be same. If they are same, then only we can say that limit as x tends to a f of x exists. Remember students, limit as x tends to a f of x is equal to L exists only when left hand limit is equal to right hand limit. What do you mean by left hand limit? Limit as x tends to a minus f of x, that is left hand limit. Limit as x tends to a plus f of x is the right hand limit. So both should approach to the common value. Then only we can conclude that limit of a function exists. That is limit as x tends to a, f of x is equal to L. That is as x tends to a, f of x tends to L. That is the basic concept. Afterwards you have studied about evaluation of limits. Students, you have studied, suppose if I take limit as x tends to 2 x plus 5. What you are going to do? You are going to substitute the value of x in the given f of x. So you get 2 plus 5 is equal to 7. This is direct evaluation of limits. But you know, sometimes what happens is when you take limit as x tends to 3, x squared minus 9 divided by x minus 3. For this expression, when you substitute x as 3, 3 squared is 9, 9 minus 9 is 0. 3 minus 3 is 0. We get 0 by 0 form. What is that 0 by 0 form is called? It is called as indeterminate form. When you get indeterminate form, you have to go for alternative methods to find the value of the limit. So how we are going to evaluate this limit as x tends to 3? I write it as x plus 3 into x minus 3 divided by x minus 3. What I have done here? I have written x squared minus 9 as x plus 3 into x minus 3. So x minus 3 gets cancelled. Now substitute the limits. 3 plus 3, that's equal to 6. 6 is the value of this limit. I think you have understood how to get this. This is how we evaluate limits. First, substitute the value of the x in the given expression and check whether it takes indeterminate form or not. If it takes indeterminate form, then we have to go for other methods by which we can find out the value. See, here we have used the method of factorization, or you can sometimes you may have to use standard formula to evaluate the limit. So suppose if you do not get indeterminate form, then value obtained itself is the limiting value. So I think you have understood how to evaluate limits, and afterwards you have studied about algebra of limits. What is that algebra of limits? Algebra of limits, these are all you have studied in first PUC, algebra of limits. Suppose if you take limit, let us if you assume limit as extends to a, f of x is equal to say some m, limit as extends to a, g of x is equal to some n. Suppose if these two limits are defined, then I conclude limit as extends to a, f of x plus g of x is nothing but l plus n. That's what m plus n. Similarly, second algebra of limits, limit as extends to a, f of x minus g of x. Suppose if you take difference, it will be m minus n. Suppose the third one I take, limit as extends to a, f of x into g of x. So f of x into g of x, this will be m into n. I take up the fourth one, limit as extends to a, f of x divided by g of x. This will be m by n, where g of x is not equal to 0. Limit as extends to a, g of x is not equal to 0. Suppose if it becomes 0, then it is not at all defined. Then the fifth algebra of limits, limit as extends to a, k into f of x. Suppose if you have k into f of x, you take k outside and limit extends to f of x is nothing but m. Answer is k into m. You need to know the basic. So limit of the sum is sum of the limits. Limit of the difference is difference of the limits. Limit of the product is product of the limits. Limit of the quotient is quotient of the limits. Limit of constant into function is constant into limit of the function. These are the 5 algebra of limits you need to know. So far I have told you about the concept of limits. We need to know the basic standard formula. So formula related to limits we need to consider. Basic formula, limit as extends to a, x power n minus a power n divided by x minus a. That will be n into a power n minus 1. This is the basic formula which you have learned. This is very, very important. Second one, limit as extends to 0, sin x divided by x. It's always equal to 1. You know this formula, we have proved this using sandwich theorem. And third one, limit as extends to 0, tan x divided by x. This is also equal to 1. Then fourth one, limit as extends to 0, 1 minus cos x divided by x. That's equal to 0. We have proved this. Similarly, we have got limit as extends to 0, e power x minus 1 by x. That's equal to 1. Sixth one, limit as extends to 0, a power x minus 1 divided by x. That will be log a to bc. These are the basic 6 formulae. Apart from that, we have some more formulae regarding the exponential limits. Limit as extends to 0, 1 plus x whole power 1 by x is e. Limit as n tends to infinity, 1 plus 1 by n whole power n is equal to e. And limit as x tends to n tends to infinity, 1 plus x by n whole power n, that is equal to e power x. All these basic formulae are there, but these 6 formulae we use it often. Students, remember, so far I have told you about the limits. I have not entered into continuity. So I have told you about the definition of limits, then evaluation of limits, algebra of limits, basic formula of limits. All this you have studied in second PUC, and we have solved more than 35 to 40 problems in the first PUC textbook. So if you know all these basic concepts, then only you can learn continuity well. So I think you have understood when the limit of the function exists. Remember, limit as x tends to a f of x is equal to L means as x tends to a f of x tends to L. So when the limit of the function exists, always remember left hand limit will be equal to right hand limit. That means say limit as x tends to a minus f of x will be equal to limit as x tends to a plus f of x. Then I have told you about the evaluation of limits. To evaluate limits, you have to substitute the value of x in the given function, check whether it takes indeterminate form or not. If it does not take indeterminate form, whatever the value we have got, that is the value of the limit. Suppose if it takes indeterminate form like 0 by 0, infinity by infinity, etc., then you have to simplify the expression by any methods. Like you can use factorization, you can use rationalization, or you can use standard formula to evaluate. Next, I have told you about the algebra of limit. These are the basic operation I have told. I have not taught you limit of the logarithmic functions, limit of the exponential function. I have not mentioned here. I have told you about the basic operations. Then I have told you about the important formula. Limit as x tends to a, x power n minus a power n divided by x minus a is n into a power n minus 1. Limit as x tends to 0, sin x by x is 1. Limit as x tends to 0, tan x by x is 1. Limit as x tends to 0, 1 minus cos x by x is 0. Limit as x tends to 0, e power x minus 1 by x is always 1. Limit as x tends to 0, a power x minus 1 by x is log into base e. You should know all these basic formulae to start with the study of continuity. So let us take up the concept of continuity. I think you have written all these formulae in detail. So I start with continuity. Students, remember, we consider a function y is equal to f of x. It may be any function. That means to say it may be a logarithmic function, or it may be a algebraic function, or trigonometric function, or exponential function, whatever function it may be. When the function is said to be continuous, in a simple sentence and simple way I am going to teach you about continuity. Very simple. When the function is said to be continuous, very simple. See, to check for continuity, you just find out the limit of the function f of x as x tends to, because continuity will be discussed generally at a particular point. So when you find out the limit of the function f of x at x is equal to a, if that value becomes equal to f of a, limit as x tends to a f of x, if that becomes equal to f of a, then the function is said to be continuous. Remember, a function is said to be continuous if and only if limit as x tends to a f of x is equal to f of a. So in other words, limit as x tends to a minus f of x is equal to limit as x tends to a plus f of x is equal to f of a. That's what we get. That means to say left hand limit should be equal to right hand limit, and it should be equal to f of a. Remember students, we have already told you limit as x tends to f of x means left hand limit should be equal to right hand limit. Not only the limit of the function exists, that value should be equal to f of a. Then only we can say that the given function is continuous. Remember, the function y is equal to f of x is said to be continuous at x is equal to a if limit as x tends to a f of x is equal to f of a. That means to say limit as x tends to a minus f of x is equal to limit as x tends to a plus f of x, that's equal to f of a. Then the question comes, when it is said to be discontinuous? When the function is said to be not continuous or discontinuous? Remember, function is said to be discontinuous if limit as x tends to a minus f of x is not equal to limit as extends to a f of x. A plus f of x. That means when left hand limit is not equal to right hand limit. So when left hand limit is not equal to right hand limit, then you conclude that limit of a function does not exist. When limit of a function does not exist, there is no chance for continuity. So we conclude that this is the discontinuity of first kind. That is, left hand limit is not equal to right hand limit. Limit as extends to a minus f of x is not equal to limit as extends to a f of x. Then the function is said to be discontinuous. Remember. Then another case is there. What is the another case? Even though limit as extends to a minus f of x is equal to limit as extends to a plus f of x. Left hand limit is equal to right hand limit means what is the conclusion? Limit of a function exists. And if it is not equal to f of a, limit of a function exists. That means, in other words, we say that limit as extends to a f of x is not equal to f of a. Limit exists, but if it is not equal to f of a, then also the function is said to be discontinuous. This is the condition for continuity, this is the condition for discontinuity. Once again, understand students, a function y is equal to f of x is said to be continuous. You have to write them. A function y is equal to f of x is said to be continuous at x is equal to a. If limit as extends to a f of x is equal to f of a. That means to say limit as extends to a minus f of x, left hand limit, is equal to limit as extends to a plus f of x, that is right hand limit, that's equal to f of a. So when LHL is equal to RHL is equal to f of a, then the function f of x is said to be continuous. So here we have conditions for discontinuity or not continuity of a function. A function y is equal to f of x is said to be discontinuous or not continuous at x is equal to a if limit as extends to a minus f of x is not equal to limit as extends to a plus f of x. That is, left hand limit is not equal to right hand limit, means limit of a function itself does not exist. That is called as discontinuity of first kind. What is the discontinuity of second kind? LHL will be equal to RHL, left hand limit will be equal to right hand limit, but it is not equal to f of a. Then the function is said to be discontinuous. That is, limit of a function exists, but it is not equal to f of a, then the function is said to be discontinuous. Remember students, graphically speaking, suppose if a function is said to be continuous, then there will be no break in the graph of the function. Suppose I have taken an example, there is no break in the graph of the function. Suppose when the function is discontinuous, suppose remember, there will be a break in the graph of the function. Suppose if I take this as x is equal to k, we say that there is a break in the graph of the function at x is equal to k. I conclude that it is not continuous at x is equal to k because there is a break in the graph of the function. That you have to understand. Graphically speaking, if a function is said to be continuous, then there is no break in the graph of the function. Suppose if the function is discontinuous or not continuous, there will be a break in the graph of the function. That's what you need to remember, the basic definitions. If you know this definition, definitely you can score the marks. Suppose, let us take an example. Let us consider the function f of x is equal to x squared at x is equal to 0. You are asked to test or examine the continuity of the function f of x is equal to x squared at x is equal to 0. Let us see. Let us take limit as extends to 0 f of x. What happens? Limit as extends to 0 f of x. F of x is nothing but x squared. Okay? Substitute the limit, 0 squared is equal to 0. So limit as extends to 0 f of x is equal to 0. The limit of a function exists. Now f of x is equal to, you have x squared. You take up f of 0. F of 0 is 0 squared, which is 0. So if we put x as 0, 0 squared 0. So what happens now? Limit as extends to 0, f of x is equal to f of 0 is equal to 0. So what is your conclusion? Function f of x is continuous at x is equal to 0. That's what our conclusion is. See here how to write the graph. You know y is equal to f x square or f of x is equal to x squared is a parabola. It will be like this, parabola graph. So you can see that it is continuous. Hence, I conclude that f of x is equal to x squared at x is equal to 0 is continuous. I think you have understood how to solve this problem. Remember, function is said to be continuous if limit as extends to 0, f of x is equal to f of a. Suppose if it is asked that x is equal to 0, limit as extends to 0, f of x is equal to f of 0. That's what we have proved, and even we have written the graph also. Think you have understood this problem. So check. So a function is said to be continuous at x is equal to a if limit as extends to 0, f of x is equal to f of a. Function is said to be discontinuous at x is equal to a if limit as extends to a, f of x is not equal to f of a. Let us move on to the next question. Let us solve few problems. It is given test for continuity of f of x is equal to 2x plus 3 at x is equal to 1. You have to test the continuity for f of x is equal to 2x plus 3 at x is equal to 1. So you know the definition. So you take limit as extends to 1 f of x, then limit as extends to 1 f of x is 2x plus 3. What happens now? 2 into 1 plus 3. What is the answer you get? 2 plus 1, 2 plus 3, it is equal to 5. Now f of x is equal to 2x plus 3. F of 1 is equal to 2 into 1 plus 3. 2 plus 3 is equal to 5. So what is your conclusion? Limit as extends to 1. F of x is equal to f of 1. This is also 5, this is also 5. I conclude f is continuous at x is equal to 1. So I conclude f is continuous at x is equal to 1. I think you have understood how to solve this problem. They have given f of x is equal to 2x plus 3 at x is equal to 1. You have to check for continuity at x is equal to 1. This is the thing, and you can write the graph also. Very simple graph you can write. It has been asked that x is equal to 1, 2x plus 3. How the graph will be? You take it like this. How to plot the graph? So for y is equal to 2x plus 3, if you put y as 0, x will be minus 3 by 2. Suppose it will be minus 3 by 2 here. Suppose if you take x as 0, y will be 3 somewhere here. So the graph will be like this. And they have been asked to test the continuity at x is equal to 1. Let us take x is equal to 1 like this, and this is the graph. So this is the graph of y is equal to x plus 3. I think you have understood how we have plotted the graph. Suppose if I take y is equal to 2x plus 3. Very simple. See here, put x is equal to 0, then y is equal to 3. Y axis it is 3 here. If you put y as 0, 2x plus 3, 0. X will be minus 3 by 2. Minus 3 by 2 means somewhere here, minus 1.5. You mark a point on x-axis, mark a point on y-axis, join them. So you at x is equal to 1, you can see that it is continuous. I think you have understood this problem. The simple way to solve the problem. Examine the continuity at for f of x is equal to x plus 3 at x is equal to 1. Next, let us take examine the continuity of the function f of x is equal to 5x minus 3 at x is equal to 0, x is equal to minus 3, and at x is equal to 5. At these 3 points you need to check. Very simple. Let us take how the graph will be if I take this as y is equal to 5x minus 3. See, very simple way we can plot the graph. See, very simple way. See, this is x-axis, y-axis. Put y as 0. If you put y as 0, 5x minus 3 0. What is 5x minus 3? 0 means x is equal to 3 by 5. It is less than, x is equal to 3 by 5, less than 1, somewhere we point, positive x-axis. Put x as 0. What happens if you put x as 0? Y will be minus 3. Where that minus 3 will be? Somewhere here, minus 3. So you have to join these two and you can extend this. So at x is equal to 0, if you take, it is said to be continuous. How we can say that it is continuous? Because there is no break in the graph of the function. I think you have understood how to find out this. If you put x as 0, y will be minus 3. If you put y as 0, x will be 3 by 5. That's how we have written this. And you can see at x is equal to 0, at x is equal to minus 3. Somewhere you can get minus 3. If you extend this, it is said to be continuous. Suppose if you take x is equal to 5 here, you can see that it is a continuous graph. It goes up to infinity. Now let us take limit as x tends to 0. F of x is equal to limit as x tends to 0. F of x 5x minus 3. So apply x is equal to 0. 5 into 0 minus 3 minus 3. So what is f of x now? 5x minus 3. F of 0, x 5 into 0 minus 3, we get minus 3. I think you have understood. See, limit value is minus 3. F of 0 is also minus 3. So I conclude limit as x tends to 0, f of x is equal to f of 0 is equal to minus 3. So from the graph also we can conclude f is continuous at x is equal to 0. So similarly you can examine the continuity at x is equal to minus 3 and at x is equal to 5. It is left as homework. We need to solve this. So what we have done here, first we have found the limit at x is equal to 0. We have got the answer as minus 3. Then we have found f of 0. F of 0 has become minus 3. Since limit as x tends to 0, f of x is equal to f of 0. So we have proved that f is continuous at x is equal to 0. Let us move on to the next question. Now let us take the next question. Examine the continuity of the function f of x is equal to 2x squared minus 1 at x is equal to 3. At x is equal to 3. So you need to calculate this. F of x is equal to 2x squared minus 1. Let us take limit as x tends to 3 f of x. Limit as x tends to 3, f of x is nothing but 2x squared minus 1. I think you have understood this. So let us substitute 2 into 3 squared minus 1. 18 minus 1, it is equal to 17. Let us take f of x is 2x squared minus 1. Substitute x is equal to 3. 2 into 3 squared minus 1. 18 minus 1 is equal to 17. So what you can conclude now? Limit as x tends to 3, f of x is equal to f of 3. So conclusion is f is said to be continuous. So you can plot the graph easily. If you put x as 0, y will be minus 1. If put x is equal to 0, y will be minus 1. Put x is equal to 1, 1 squared 1, 2 into 1, 1. 2 minus 1, 1. Y will be 1. So in such case, how the graph will be? Let us take how the graph will be. X and this is y and this is 0. And when you put x as 0, y will be minus 1. So this is clearly 2x squared minus 1 is clearly it is a parabola. Clearly it is a parabola. The graph will be like this. Graph will be like this. So what is your conclusion? Our conclusion is it is said to be continuous. So just for the sake of understanding, I am writing the graph. So it is not compulsory. It is not compulsory to write a graph, but if I write a graph, you will understand that there is no break in the graph of the functions. Since there is no break in the graph of the function, it is obviously continuous. I think you have understood how to solve this. First, find out limit as x tends to 3 f of x. You have got 17. Then f of x, you put x is equal to 3, you get 17. Limit as x tends to 3, f of x is equal to f of 3. I conclude function is said to be continuous. Think you have understood this problem. I take up the next problem. Discuss the continuity of f of x is equal to mod x at x is equal to 0. One of the important problems it is. So, what do you mean by f of x is equal to mod x? Already you have studied in first PUC regarding the definition of modulus function. It is said to be x if x is greater than or equal to 0. It is said to be minus x if x is less than 0. This is what the definition you have. Now, limit as x tends to 0 minus. Why we have to take left hand and right hand limits here? Because the function is defined for x greater than 0 and also for x less than 0. Limit as x tends to 0 minus f of x is equal to limit as x tends to 0 minus limit as x tends to 0 minus f of x. So 0 minus means left hand limit. Which is the function defined for x less than 0? It is minus x. So answer is 0 minus. Minus 0 is 0. Limit as x tends to 0 plus f of x will be limit as x tends to 0 plus f of x. 0 plus means right hand limit. Identity the function defined for greater than 0, it is x. So what happens when you substitute the value? It becomes 0. So left hand limit is 0, right hand limit is also 0. You take f of x as x, you want f of 0, that's equal to 0. See here, for x is equal to 0, it is equal to x. What is your conclusion now? Limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x, that's equal to f of 0. So, left hand limit is equal to right hand limit, that's equal to f of 0. Hence, f is said to be continuous. This function, modulus function is said to be continuous. See how the graph will be. This is x-axis and here it is y-axis. You have understood about modulus function, you have written the graph also. Graph of the function will be like this because it is above x-axis. So for x is equal to 1, it is 1, y is equal to 1, 1, 1, minus 1, it is like that. So you can, from the graph it is clear that it is continuous at all the points. Especially at x is equal to 0, it is said to be continuous. Please understand properly, you have been given modulus function. If you know the definition, then only you can solve the problem. F of x is x if x is greater than or equal to 0. It's minus x if x is less than 0. So for left hand limit we have to take minus x. For right hand limit we have to take plus x. For x is equal to 0 you have to take plus x. Because it is x when x greater than or equal to 0 and minus x for x less than 0. I think you have understood this problem. This is a very important problem regarding the modulus function. You need to understand it properly. Students, in this class we have solved many problems on continuity. First of all, I gave you the insight about limit of a function, then we have moved on to continuity. I think you have understood both of these concepts. In the next class we are going to solve more problems on continuity. That's all for the day. Thank you.